Welcome to this explainer. Today, we're diving into some advanced AWS architectural patterns. I'm your host, and I'm joined by our resident AWS Cloud trainer. We're going to decode some real-world, high-stakes DevOps scenarios to get you totally ready for those tough certification exams.
Hey everyone, glad to be here. Going beyond the basic tutorials and seeing how top-tier engineers actually build these self-healing systems is absolutely crucial for your AWS journey. So let's jump right in.
Okay, here is a classic high-stakes scenario you might see. Your app is failing, logs are suddenly missing, and downtime is literally costing your company thousands of dollars every single minute. How do you find the root cause? Yeah, that's a nightmare scenario, right? And here's the thing, rote memorization of AWS services is not going to save you here. To really answer this and to fix it in the real world, you need a deep functional understanding of how these services interact under extreme pressure. We've got to lean on AWS best practices.
To tackle this, we're breaking things down into 4 foundational pillars for this explainer. First, mastering CI/CD pipelines. Second, high availability and disaster recovery. Third, security and governance. And fourth, monitoring and auto-remediation. Let's hit it.
Starting off with Pillar 1, mastering CI/CD pipelines. This is all about how we build, test, and deploy code securely.
So taking a look at the screen, we've got a Buildspec.yml file used in an AWS code build project. What's jumping out at you here?
Oh man, this is a glaring security violation. If you look closely at the environment variables, you can see AWS access keys and a database password just sitting right there in plain text. Pushing this to a code repository is a massive, massive risk. You'll definitely see questions testing you on this anti-pattern.
Okay, so if this comes up, what is the correct AWS way to fix it? The correct approach involves a few steps. First, absolutely remove those hard-coded credentials from the environment variables. Instead, update the code build project's IAM role so it has the necessary native permissions. Then, for that database password, store it as a secure string in the AWS Systems Manager parameter store. That way, during the build phase, the script dynamically pulls the secret without ever exposing it in the source code.
Makes total sense. Now, once the code is built, we need to deploy. A lot of stings get confused between code deploys in place versus blue/green deployments. Can you break that down?
For sure.
An in-place deployment updates your instances sequentially, which means there could be some downtime or impact. The better answer for high availability is a blue/green deployment. This provisions a totally new fleet of instances. That's your green environment. You use an application load balancer to seamlessly route traffic over. The big takeaway here is that blue/green ensures zero downtime, and if something breaks, rolling back is as simple as shifting the load balancer traffic back to the blue instances.
Perfect. Moving right along to Pillar 2, high availability and disaster recovery. Let's talk about staying online globally.
Here is a great global expansion scenario. Imagine a US-based retail company expanding to Europe and Asia. They need a unified global product catalog, but local compliance laws say customer data has to stay in the region it was collected. What's the right architectural choice? This is a classic exam question. You want to combine a couple of services here. The correct answer is to use Amazon Aurora for that centralized product catalog because it replicates fast globally. But for the customer information, you pair it with Amazon DynamoDB global tables, or specifically regional tables, to handle the strict data residency requirements. It perfectly balances global performance with local compliance.
So what about disaster recovery? We need strict recovery time objectives, or RTO, across regions. Manual intervention just won't cut it, right?
Exactly. You need an automated DR process. A brilliant exam pattern to look out for involves using Amazon SNS topics to listen for RDS backup events. When a backup finishes, it triggers an AWS Lambda function that automatically creates a cross-region snapshot copy. Then, another Lambda function is queued up to instantly restore that instance in your failover region. It's totally hands-off and guarantees your RTO.
Let's stick with databases for a second. Take a look at this DynamoDB thread table dataset we have here. Forums, subjects, last post dates, and threads. Right, and when you're dealing with DynamoDB, your schema design is absolutely critical. It's not just about organizing data, it's about minimizing your provisioned read capacity costs. If you get the schema wrong, your costs will skyrocket. Which brings us to the great debate: local secondary indexes versus global secondary indexes. How do we query this dataset efficiently? So if we need to search within a specific forum for subjects starting with a certain letter or fetch threads by a time frame, the most cost-effective solution is an LSI. You set subject as the primary key, form name as a sort key, and then implement a local secondary index with last post date time as its sort key.
Because an LSI shares the partition key with the base table, it's basically like a pre-sorted filing cabinet just for that forum. It prevents those super expensive full table scans.
Awesome breakdown. Let's shift gears to Pillar 3, Security, Governance, and Auditing. Remember, folks, security is always job zero in the cloud.
Now I see students mix these up all the time. AWS Config versus AWS CloudTrail. How should we remember the difference? It's an easy trap to fall into. Just remember, Config is for state, CloudTrail is for action. AWS Config constantly evaluates your resource configurations, like flagging if someone launched an unencrypted EBS volume. CloudTrail tracks the actual API calls, so it tells you exactly who launched that unencrypted volume and when they did it. You need both for full auditing.
Okay, here's a super cool auto-remediation flow. Say a developer accidentally pushes an AWS access key to a public GitHub repo. How does AWS handle this? This is cloud governance at its finest. First, the AWS Health API detects it and triggers an exposed credentials risk event. A CloudWatch events rule catches that, which instantly fires an AWS Lambda function to delete or deactivate the compromised IAM key before anyone can exploit it. Finally, an SNS topic notifies the security team. Knowing this automated flow is gold for the DevOps exam.
Let's talk data storage. What if we have strict rules for personally identifiable information, or PII, like having to store primary and secondary backups at least 500 miles apart?
For that, you're looking at secure multi-region S3 storage. You configure cross-region replication between buckets that are 500+ miles apart. To keep it fully secure, you enforce HTTPS only in transit via bucket policies and use SSC managed keys, or SSES3, to encrypt the data at rest. Always look for these specific security features in the multiple choice options.
All right, our final section, Pillar 4, Monitoring and Auto-Remediation. Let's see how systems can essentially heal themselves.
Check out this custom CloudWatch JSON event pattern on the screen. It's filtering for a code pipeline action execution state change where the state is specifically set to failed.
It looks like a simple block of JSON, but it's incredibly powerful. This acts as an automated safety net to catch failed deploy and build actions across all of your CI/CD pipelines in real time.
And why is catching that specific JSON failure state so critical for a DevOps team? Because it lets you instantly route those events using EventBridge to SNS notifications. Instead of your engineers manually digging through logs to see if a deployment worked, the system literally pings you the millisecond a pipeline breaks. You can fix broken builds before they ever impact delivery.
That's a game changer. Now, what if the app is already running? Log aggregation on an ECS cluster with multiple microservices behind an application load balancer sounds like a headache. It definitely can be if you don't set it up right. To master ECS container logging, you need 4 key steps. Install the CloudWatch Logs agent right on the instances, enable access logging on your application load balancer, enable it on your target groups, and finally, point all of those logs to a centralized S3 bucket. That gives you near real-time analytics across the whole cluster.
Okay, one final, fascinating pattern before we wrap up. Imagine a super strict production environment where any EC2 instance that gets manually logged into by a human has to be destroyed within 24 hours to prevent configuration drift. How do we automate that? I love this one. A CloudWatch log subscription filter catches the actual login event. That triggers AWS step functions, which tags the EC2 instance as compromised or slated for decommissioning. Then, a daily CloudWatch event triggers a Lambda function that just sweeps the whole environment and ruthlessly terminates any instance with that tag. The system literally purges its own anomalies.
That is wild. We have covered a massive amount of ground today, from dynamic secret injection to global DR and relentless auto-remediation.
Absolutely. These patterns show that the cloud isn't just about renting servers, it's about building living, self-healing systems. Understanding this is key to passing those advanced exams.
So I leave you with this final thought. If your infrastructure can now audit, heal, and deploy itself, what is the next frontier of cloud engineering? Think about that. Make sure to subscribe for more AWS certification content and exam preparation explainers. Keep building, keep learning, and we will see you in the next one.